Hello everyone. So this video is for Standard 7 Math. Our first topic is going to be angles and lines and pairs of angles. So without further ado, let's begin. Okay. So first we need to know how to write angles, right? So now, for example, if I had to take an angle like this, okay, and this is the angle. Say this is point A, this is point B, and this is point C. Okay. Now the rules for so typically this angle, the part where the point where the angle is at, where the lines meet, is called the vertex. So this is the vertex. Okay. Now these, so AB and BC, these are what we call as the arms. Okay, these are the arms of the angle. Now, when you're writing the name of an angle, the rule is the vertex letter always has to be in the center. So if I had to name this angle, I would call this angle ABC, right? ABC. It could also be called angle CBA. Yeah, it could be called any of those things. Yeah. So this is how we write angles. Now, the next thing which I'm going to focus on is what is in the interior of an angle and what is in the exterior. So this part, all of this is in the interior of the angle, and all of this is in the exterior of the angle. Okay, so if I say this angle would be the interior angle, and this entire angle would be the exterior angle. Okay, so that's interior and exterior angles. Now I'm going to move on to adjacent angles. So now if I had, say, a figure like this, all right, then this angle here and this angle here would be called adjacent angles. Okay, so A, B, C, and let's call this D. That means angle ABD and ABC would be adjacent to each other. Now, what makes angles adjacent is the fact that they have a common ray, all right, okay, or a common arm. This would make angles adjacent to each other. So this is a really important concept which we'll need for later parts of this chapter. So yeah. Or for example, if I had something like this, an obtuse angle, for example, then these would be my adjacent angles. Okay, so that's the concept of adjacent angles. Yeah. Okay. So this is pretty simple. We'll now move on to complementary and supplementary angles. So now if I had to take, let's say, a pair of angles, right, something, this would look a little something like this. Yeah, if I take a pair of angles, and both these angles, so pair of adjacent angles, and both these angles, if I added them, would give me 90 degrees. So if this angle, this particular angle was 90, then I would say that these two angles would be complementary. So just to make it clear, if I had to put a name, I'd say A, B, C, and D. And so if angle ABD plus angle DBC would equal to 90 degrees, all right, which is angle ABC, then ABD and DBC are complementary. So they add up to 90. Okay. Similarly, for supplementary, it would be the exact same concept, except that the sum of the angles would be 180 degrees. So, for example, if I had to take a straight line, okay, I had to take a straight line, right? And then if I had to put a pair of angles here, something like this, then these angles would add up to 180 because a straight line is always 180 degrees, and therefore they would be supplementary. So here, if I took this, if I took this as A, took this as B, took this as C, and took this as D, then angle ABD plus angle ABC would be equal to 180, and therefore they will be supplementary. Okay, so that's supplementary and complementary angles. So now let's see if we can put this into practice with a sum. So for example, if there's a question which says, find the measure of the complement of an angle of measure 70. So find the measure of a complement of an angle, which is 70, which means complement of an angle, which is 70 means that 70 degrees and this angle, let's call this angle X, all right? Or let's call this angle A, all right, which is equal to X degrees. That means this angle, which is 70 plus this angle A, all right, is equal to 90. So A is the complement of 70. Now let's say let angle A be equal to X degrees. That means 70 plus X degrees will be equal to 90. So X will be equal to 20 degrees. All right. So 20 is the complement of 70. Okay. Or for example, if the question said that angles of measures A plus 15 degrees and 2A degrees are complementary, what is the measure of each angle? So what do we have? We have angles of A plus 15 degrees, okay, and 2A degrees. Yeah. So now, if they're complementary, that means that A plus 15 plus 2A is equal to 90. So therefore, A plus 15 plus 2A is equal to 90. Therefore, 3A is equal to 75. And so A is equal to 25. But now this doesn't end your sum because if the question asked you to find what are the angles, then you would have to say that A plus 15 would be 25 plus 15, which is equal to 40 degrees, and 2A, which would be 2 into 25, which would be equal to 50 degrees. And 50 plus 40 is equal to 90 degrees, right? So therefore, this is how you can prove that they are complementary. So 50 plus 40, 50 and 40 would be your answer to this type of question, yeah? So that's supplementary and complementary angles which we've got. Now moving on, let's take an example of supplementary angles. So let's take a similar example. If I had A plus 30 degrees as one of my angles, and I had 2A as one of my examples, and the question said that they were supplementary and I need to find the angles, then you do A plus 30 plus 2A would be equal to 180. And so 3A plus 30 would be equal to 180. And so 3A would be equal to 150. 180 minus 30 would be 150. So A would be equal to 150 upon 3. So A would be equal to 50 degrees, right? But now again, we need to substitute it back into what is given in our question. So here A plus 30 would be 50 plus 30, which would be 80 degrees. And here you'd have 2A, which become 2 into 50, which would become 100 degrees. And so 100 plus 80 would give me 180. And so therefore they are supplementary. And this would be your answer. Okay. So that would be supplementary and complementary angles. Yeah. Now we'll move on to vertically opposite angles. Okay. Now, before we do that, let's say you have two rays, okay, like this and like this. They intersect each other here. Okay. Now, if these are obviously straight lines, yeah. If I say that this angle is, let's say, x degrees, then if these are supplementary, this would be 180 minus x degrees, right? Now, why are these supplementary? Because a straight line is always equal to 180 degrees. So therefore, these two angles are supplementary, right? So if this is x, this would be 180 minus x, because x plus this angle would be 180. So therefore, this angle would be 180 minus x. Now, if I had to take this as 180 minus x and say if these two are also supplementary, right? Because they also lie on a straight line, this angle and this angle here, then that would mean that 180 minus x, all right, plus this particular angle here. So let's take it as, let's say this would be y, would be equal to 180, right? And so therefore, if I had to take y is equal to 180 minus 180 plus x, simply transposing all these values, this would become 0 and this would become x. So y is equal to x. So now, therefore, this angle would be x degrees as well. Okay, this angle would be x degrees. Fine. And again, in the same way, applying the same concept, these two angles, this angle and this angle, would also be supplementary because they also lie on a straight line together. So then this would be again x, and this would also be 180 minus x. Okay. Now, if you notice here, this angle and this angle, this angle and this angle are the same value, and this angle and this angle are the same value. So the vertically opposite angles are this pair of angles and this pair of angles. So vertically opposite angles are equal, and they vertically opposite means they are vertically opposite to each other, as in they lie, they form between two opposite rays. Okay, so if you have a cross pattern like this, where you have two lines are intersecting, then in such a case, this is what is known as vertically opposite angles. Okay. Now I'm going to move on to interior and exterior angles of a triangle. All right. Now in a triangle, okay, just 1 second. Yeah. So in a triangle, say I have a triangle like this. Okay. And I name it as A, B, and C. Okay. Now, this angle, and this angle, angle A, angle B, and angle C. Okay. By the way, for naming an angle, you can, for a short form, you can also simply name it by its vertex. So if I'll call this angle B, I'll call this angle C, and I'll call this angle A. But this is only applicable when there's only one possible angle for each vertex. So if I had to kind of extend this here, and if I had to call this D, then I can't call this as angle A. Then I have to call it as CAB or BAC to specify. Okay, just a little bit of information there. So now moving on, these are all interior angles of a triangle. But again, in the same way, if I had to extend any of these lines, okay, if I had to extend them, then angles formed here would be exterior angles for the triangle. Okay, or even if I had to extend it here, then these would be exterior angles. Okay, now there is an exterior angle property here, which is very important to know. Okay, now again, I'm going to take the example of X, for example. Okay, say I name this angle hypothetically as X. Okay, and I wanted to find the measure of this angle. Okay, let's call this point D. Okay, if I want to find the measure of ACD. Now, again, supplementary pairs of angles. This would be 180 minus X. Okay, now here, okay, um, so in this case, this works. Say, for example, now these two angles, all right, these two angles and this angle X. There's a property which is called the angle sum property of triangle. Okay, angle sum property, which says that all the angles in a triangle is equal to 180 degrees. Okay, that means this angle plus this angle plus this angle, angle A plus angle B plus angle C will all equal to 180. Now, if that is the case here, then what you would do is, if this is already X, that means that the sum of these two angles will be 180 minus X, because you have X plus angle A plus angle B, which would be equal to 180, right? And so therefore angle A plus angle B is equal to 180 minus X. Now 180 minus X is also the same value as this angle ACD. And this is what the exterior angle property of a triangle is, where that the exterior angle is equal to the sum of its two opposite interior angles. Now remember, that does not include this one, because here it is supplementary. Angle C is supplementary to angle ACD, and ACB, they are supplementary. But the sum of angle A and angle B will be equal to angle ACD. And that is what the exterior angle property of a triangle is. Okay? All right. And now, just to maybe put what we've done into practice in a sum. Okay, so say now I take a triangle such as this. All right, 1 second. Okay, say there's a triangle here and there's an extension here. All right, and sorry, yeah. So let's take, say this is A, this is B, this is C, and this is D. All right, and I know that this value, say, is 140 degrees. Okay, so this value is 140 degrees. And the question asks me that the measures, so the question says that the measures of angle A and B are equal. If the angle of ACD is equal to 140 degrees, then find the angles of A and B. Okay, so if this is 140, this angle and this angle have been set to be equal. So let's say take them as X, and this will also be X. Okay, these two angles are equal, and I need to find these equal angles. All right, now again, by supplementary rule, what do I know about this angle? This will be 180 minus 140 because they're supplementary. So that means this will be 40 degrees, right? Okay, so let's say angle ACB is equal to 180 minus 140, which would be equal to 40 degrees. Why? Because they're supplementary angles. Okay. All right. So now we know that this is 40. Now you will use your angle sum property of a triangle. All right. So therefore, all three angles will be equal to 180. And that means that x plus 40 will be equal to 180. Right. So that means 2x will be equal to 140. So that means x will be equal to um, 70 degrees. Now, another way to do this would be a shorter way, right? This is using supplementary angles, but another way to do this would simply use your exterior angle property. And because you know that the sum of angle A and the sum of angle B will be equal to this angle, that means 2x will be equal to 140 anyways. So x will be equal to 70. And it is actually just a two-step sum that you can do. But I've shown it both the ways just for better understanding. All right. So either way, it's correct both ways. Okay. But then just remember to justify your reasons properly. Okay. So that is also done. And um, say, for example, now that I had a figure like this, right? Say I had a figure like this. Okay, where I had two intersecting lines. All right. And I had a straight line going through in between. Sorry, like this. All right. Now, maybe we can move this up a bit. No, we can't. Okay. So now what's given to me in the question is that this angle, all right, is 8y. Okay. This angle is 8y. And these two angles are 4y and 6y respectively. Okay, so now this is what it is. All right, and now if I just had to name the figure as, let's say this was A, this was, let this be point O, this can be B, C, D, E, and F. Okay, so 8y, 4y, and 6y. Okay, now what do we know here? Okay, first thing is these two angles here, this angle COD and AOF will be vertically opposite because these two lines are intersecting, and vertically opposite angles are equal, which means this angle will be equal to 8y. Now, supplementary angles does not only need to work for 2, it can be 2 or 3 also. All of these are angles in a straight line, right? That means that 4y plus 8y plus 6y will be equal to 180 because all of these are in a straight line, which means the sum of all these three angles will be equal to 180, right? So 18y is equal to 180, right? That means that y will be equal to 10, all right? 180 upon 18, which will be equal to 10. So now we know the value of y is 10, all right? Now we want to find all the values of all these angles, right? Now, again, all right, again, because of vertically opposite angles, okay, because of vertically opposite angles, this will also be equal to 4y and this will also be equal to 6y. All right, look at these two angles and look at these two angles. They will also be vertically opposite. So in the same way, basically now you just have 6y, 8y, 4y, 6y, 8y, 4y. And so you can easily find the values, the measures of all these angles as 60, 80, and 40. All right, just simply multiplying by the value of y, which we found as 10. All right, so that means this would be 40, this would be 80, this would be 60. All of this adds up to 180. This would be 60, this would be 80, and this would be 40. All of this adds up to 180, and they're all fulfill their vertically angled properties. All right, and so that really is the end of this chapter. There's just one other thing where if, for example, I had to say, if I had to take a line here, and if I had to take another line here, then there's another name which is called for these two angles besides them being a supplementary pair, which is also called a linear pair. A linear pair of angles is when two angles lie on the same line, but they're equal to 180. All right. So that therefore these two angles would be a linear pair of angles. All right, because they lie on the same line adjacent to each other, which is very important as well. All right. But yeah, that ends this particular topic. Thank you for watching. I hope that this helped any of those viewers who watch this video, and there will be more to come. Right. Thank you.